Welcome to Runtime Atlas. Today we will take a quick look at the Kubernetes scheduler. Quick recap from the last session: the API server is the front door. The scheduler does not write directly to etcd. It watches the API server, then sends its decision back through the API server. The scheduler answers one important question. This pod needs to run somewhere, so which node should get it? It is not starting containers yet. It is making a placement decision. When a pod is created, it can exist in the API without a node assigned yet. That is the scheduler signal. Here is a pod that needs placement. The scheduler watches the API server for pods that do not have a node. You can think of those pods as a waiting line of scheduling work. This boundary matters. The scheduler does not pull images, it does not start containers, it does not talk to the container runtime, it chooses a node. The kubelet on that node does the running work. First comes filtering. Kubernetes removes nodes that cannot run this pod. Maybe there is not enough CPU or memory. Maybe the pod has a constraint that this node does not satisfy. A pod can ask for CPU and memory. The scheduler compares those requests with what each node can still offer. A node that cannot fit the request should not be chosen. Resources are not the whole story. Scheduling can also consider labels, node selectors, affinity, anti-affinity, taints, tolerations, topology, and other policy constraints. After filtering, the scheduler has a feasible set. If the set is empty, the pod stays unscheduled for now. Kubernetes can try again when the cluster changes. If several nodes can run the pod, the scheduler scores them. Scoring is how Kubernetes ranks the remaining choices and looks for the best placement. The scheduler picks the node with the highest score. If more than one node has the same top score, Kubernetes can choose one of them at random. After choosing a node, the scheduler notifies the API server. This is called binding. The pod object now records the selected node and the cluster can move forward. Once the pod is assigned to a node, the kubelet on that node sees it through the API server. Then kubelet works with the container runtime to start the containers. If no node fits, the scheduler does not force the pod onto a bad node. The pod can remain pending until resources, labels, or constraints change enough to make placement possible. The default scheduler is kube-scheduler, but Kubernetes is designed so scheduling behavior can be configured or extended. The core idea stays the same: watch, filter, score, and bind. When a pod stays pending, debug the path in order. Is the pod requesting too much? Do labels or affinity exclude every node? Is a taint blocking it? What do the pod events say? Here is the mental model. The scheduler watches for pods with no node. It filters impossible nodes, scores the feasible ones, binds the winner through the API server, and then kubelet runs the pod.